We said when we were talking about dipoles that the dipoles were a positive and a negative ion, or a positive and a negative charge separated by a small distance. And we defined a term called electric dipole moment. And we said that that was a product of one of the two charges. The two charges have to be equal and opposite, and the distance between them. And then we calculated, and I said we were going to do these three things. Out of those, we did the first one the other day, and that was the electric field that was set up due to a dipole. Now, the number two thing that we're going to do is what happens when we put the dipole in an external field. What does that dipole experience? Okay, so that's the other thing. And the last thing is, what is the potential that develops due to a dipole? So those are very mathematical calculations, but I think it's going to be very good for us to see it once. Okay, so here it goes. Number two, when we put the dipole in an external field, what happens? So remember we did this derivation? And we found that the electric field due to dipole was divided by x cubed. And if you look carefully, by the way, think about what it is. It's kqd over x cubed, right? So one of the, if I do dimensional analysis, it's kq 1l divided by l cubed will reduce to kq over l squared, which is basic definition of an E field, right? So numerically or dimensionally, this is correct. This was just me showing you, so ignore that. What happens when we take this electric dipole and we put it into an external field? Okay. So number two, when we put the dipole in an external field, suppose the E field is a very simple E field. Plus and minus. And I put a dipole in it. And there's a D in the middle. What does this dipole experience? This dipole experiences a force either along the direction of E or against it. So for the positive charge, it experiences a force, and then for a negative charge, that experiences a force. If I think about the magnitudes, is the magnitude equal? The force that the plus charge experiences and the minus charge experiences, correct? But the plus force going this way, force going that way, add one plus and one minus. Okay, now what happens when it experiences that force? Will this do that? It will twist, correct? In the, it's not moving forward, I'm sorry, but I don't know how else to animate it, so it just moves, right? So this is what it's going to experience, right? Still plus and minus. So imagine it stays the same, but it's going to twist. What's the magnitude of this force that it experiences? Let's say I call it F plus. Is that QE? And F minus, is that minus QE? Will F plus and F minus be equal? And will they be opposite? And will they cause twisting? And is that twisting force called torque? R cross F? So remember the difference between forces and torques? Forces are what cause linear motion. Torques are the same forces if they cause rotation. And remember, this is a cross product in the middle. Do we also remember when more than one force acts on an object, we call it net force, sigma F? Is that also going to be true for torques? So may I write the two forces as torque due to plus and torque due to minus? And may I also write this as is that a correct statement? Then may I write this as RF sine of theta plus RF sine of theta plus minus. Is the R in this case D over 2? So may I replace this by D over 2? And is this FQE? And is this sine theta plus D over 2 magnitude QE sine of theta? Does this become DQE sine theta? Did we call this P? From here? So may I replace that by vector P times E? A cross product resulting in the net torque.